All right, we're moving on with this chapter here, guys. Second part of the chapter is about work. First part was about energy. Second part's about work. Okay, they are related. Okay, so work. There's a couple ways to look at work. Okay, work is force times displacement. So W equals F times D, we could say. Okay, so if we apply a force for a certain amount of distance, we do work. Okay, work also is equal to the change in energy. In other words, if you do work on something, we say you can change its energy. In other words, you could speed it up to make it have more kinetic energy. You could actually slow it down to have less kinetic energy, or you could even like lift it. If you lifted it up in the air, you'd be adding potential energy. So when you apply a force over a distance, you are also going to change the energy state of that object. And it really works out that they're actually equal. Work is equal to the change in energy. We'll look at two examples. How about lifting a mass? So let's say this guy's lifting up this mass. Got good squatting form. Say a 7-kilogram bowling ball, and he's going to lift it up above his head to a height of 1.5 meters. Okay, so he's applying a force to lift it a distance, right? So the question is, how much force does he actually have to pull with? Well, it's just the gravity force of that bowling ball, right? Remember this? Okay, 7 times 9.8. Oh no, okay, 7. I thought my calculator was dead. 7 times 9.8, 68.6. He's actually going to push upwards though, right? Because he's going to overcome the gravity force. So I guess you could say the gravity force is negative, but he's going to push up. So his work is going to be 68.6 newtons upwards for 1.5 meters. Okay, so 102.9. Now what it works out to for units, because it's also change in energy. If you think about energy was joules, so change in energy is also going to be joules. So really he did 102.9 joules of work. Okay, let's look at another example that kind of relates to that. Let's say you're pushing something up an incline. Say a 30-degree incline. And let's say it's 3 meters here actually on the incline. And let's say it's, same thing as a ball. And we're going to push it up and we're going to get it up here to the top. Okay, so apply this force. Let's say weighs 7 kilograms. And then this distance is going to go as 3 meters. So how much work does it take to get it to slide up there? Okay. Now we could figure out the gravity force, but if you remember from inclines, the force to push it up a ramp is actually going to be less than the gravity force. In this case, I calculated it out already. It's going to just be 34.3 newtons. Okay, so you're pushing it up this incline and getting it to there. So pretty easy, right? Applying a force of 34.3 newtons for 3 meters. Forget this over here, sorry. Okay, so that comes out to 102.9 joules. Okay, not really a coincidence. I kind of did that on purpose as far as these coming out to the same answer. Okay, so here's the kind of the last thing to kind of tie it into what you know already is, okay, he did 102.9 joules of work to push it up here. This guy did 102.9 joules of work to lift it here. The end result is getting a ball from ground level to, this is actually assuming this is 30 degrees, I kind of forgot to tell you that, and this would be 1.5 meters, right? It's going to be half because of 30 degrees. So assuming this started at ground level and it basically got up to a height of 1.5 meters. Same thing here, started at ground level, got up to 1.5 meters. So the end result's kind of the same. They both just basically raised the ball 1.5 meters off the ground. So that's why the work comes out the same, because if you think about the change in energy, this is kind of the last thing. Let's just say, hey, what's our PE here at the ground? Well, that was 0, right? And then we get to the top. What's the PE? Well, we just calculated out MGH. I mean, 7 times 9.8 times 1.5, right? Is 102.9. So that's the connection, is that the change in energy was 102.9, which means we did 102.9 joules of work. So you could have just figured this out and got the answer. So that's the connection, though. However much work you do winds up coming out equal to the change in the energy. Okay, we'll continue on that. That's what you need to know for right now.